Hey guys, welcome back. So today's objective is I can create a scattered plot with the given data and make predictions from our graph. So we're just going to go right ahead and get started, and we're going to create a scattered plot. Alright, so now what we're going to do is we're going to plot some points. Now they're already on your paper. Now these points are data points from this word problem. This word problem says that the table gives the ages and heights of 10 pine trees. Make a scattered plot of the data, then make a conclusion about the data. Now over here we have independent and dependent variables. The independent is the variable that you already know. You know, before we walk to this tree, we know the age of the tree. We know when we planted it. Then once we get there, we can take the height. So the age is the independent, the height is the dependent, because it depends on the age and how tall it is, right? So let's go ahead and write down over here. The independent variable represents the input or the cause, and it represents the x coordinate. The dependent variable is the absolute opposite of that. So instead of representing the input, it represents the output. Instead of representing the cause, it represents the effect. All right? And then instead of it being the x coordinate, it's the y coordinate. So these points right here, this being, again, we have the independent is the age, the dependent is the height. So this first point would be x. This whole row is going to be the x, and then this whole row is going to be the y. So this first point, I know it doesn't really matter because they're both the same number. It's the point 0, 0. Now this is where, when they're different, that's when it does matter. The 1 has to be the x, the 2 has to be the y. 6 and 4, we know the 6 is the x, the 4 is the y. Alright, so on and so forth. So go ahead and write all these points down. If you need to press pause to write them down, go for it. So there's all 10 points, all 10 data points. Now we're going to go ahead and plot these points. Now to plot them, we have to see what range we have. Now over here we have for the independent variable, actually the dependent variable, which is the height. The highest number we have is 34. As you can see, we have 10 units here. So a good number to go up by would be 5s. So we got 5, 10, 15, 20, 25, 30, 35, 40. Okay. Now the independent variable, the age, would go on the x-axis. Again, the x-coordinate is the independent variable, so the x-axis is going to be labeled with the independent variable. Okay, now we're going to go ahead and put our points in here. There's going to be 5, 10, 15, 20, 25, 30, 35, 40. Again, because the highest point in this case is 39. So going up to 40 makes sense because the highest point is 49 or 39. Okay, so now let's go ahead and plot these points. All right, so the first one is going to go right at the origin, 0, 0. Then we have 1, 2. All right, so it's floating in this box somewhere. All right, then we have the point 6, 4. So it's floating in this box somewhere. Okay, then we have 10, 8. All right, so that's that one. And I'm just going to put the rest of these points on there. If you need to press pause to draw your own points, go for it. So one more. There's all the points. Okay. Now, we can look at this data right here, and we can come up with a conclusion. Because over here it says that we have the age, over here we have the height. Now, the independent variable is always what you start with. And in this case, the independent variable is increasing because you can see that the age is increasing. So when the age increases, all right, so as the age of the pine tree increases, then the height increases as well. So this is the conclusion of this scattered plot. All right, later on in the video, you're going to have to come up with your own conclusions based on the information that's given. All right. Now, the other thing that's really nice about having a scattered plot is it can help you predict things. So I'm just going to move up a little bit. Now, what you can do is you can kind of guess where either the height or the age of something would be if you knew the other part of it. So, for example, number 1, it says, how tall is a 17-year-old tree? Now, we don't have 17 in our data pool, but we can kind of guess because over here, this is where the age is around 17. So if I look in the vicinity of where most of the dots are at that point, you can kind of guess about how tall it would be. And my guess is that it would be about 15 feet tall, because you can see that this circle I drew is pretty close to the line 15. Now, if you say 16 or 14, you'd still get full credit because this is a prediction. And you can see I put the word about there. All right. Now, what I want you to do is I want you to predict number 2 and number 3. Number 2 says, how old do you think a tree is that's 40 feet tall? So that would be in this area over here. And then how tall do you think a 55-year-old tree would be? So 55 would be around over here. I'm going to give you guys a second to do that, and then we can go ahead and continue. All right, so hopefully you got a number that's pretty close. Now, over here, this is the area where it's about a height of 40. So I guessed that the age is about 43 years old. Okay, if you had something close to that, you're good. All right. The height of a 55-year-old tree, now 55 years old, is about right here. So I guess that it's about 50 feet tall. Okay. And again, if you're pretty close to that, that's awesome. You have to at least be close. And again, I put the word about. Okay. So let's go to the back side. All right, now we're going to talk about correlation. Now, correlation, let me put down the definition there for you, is the relationship between the data points. Now, hopefully you've seen this in the past. Let's take a look at this first set of data pool. Now, go ahead and make these random dots and make them go, make them increase a little bit. So from down here, then it increases from left to right. Okay, what I'm going to write here is that the data points rise from left to right. So as you can see, the data points rise from left to right. Okay, when something rises, it kind of looks like it's becoming positive. So we're going to put positive correlation. Okay, now in the next one, this data pool has the points going downward. So what I'm going to write over here is that the data points fall from left to right. When they fall from left to right, it looks like it's going down. We're going to write a negative correlation. Now you are going to see some points that are kind of crazy like this, where they're all over the place, and you can't really tell if it's positive or negative. So what you would put in this case would be that doesn't appear to rise or fall, therefore it is no correlation. So these are the three types of correlation. Positive, it means it rises. Negative, it means it falls, it decreases. And then no correlation because it's all random and you don't have a definitive positive or negative data points. All right? All right, now what we're going to do in this part is we're going to look and see what the correlation is. We're going to talk about the independent and dependent variable. We're going to also predict some stuff about it. Okay, so what is the independent variable? Again, the independent variable is the x-axis. All right, so that would be the temperature in Celsius. The dependent variable is the y-axis, so that's over here, and you can see that that's the amount of money that the shop made. What is the conclusion? I want you guys to try to come up with the conclusion based on these data points. I'll give you a second to do that. All right, so as you can see, the temperature is rising, and since the temperature is rising, more ice cream is being sold. So that's our that's what we have here. As the temperature of the day increases, the amount of ice cream they sell will increase as well. Okay. What type of correlate? Now I want you guys to answer the next three on your own. I'm going to give you a second to do that. So it says, what type of correlation does the graph give? And predict two things for me. Go ahead and do that right now. All right, so the type of correlation here, you can see that it increases. Since it's increasing, we're going to say that it has a positive correlation. All right, now for me, I'm predicting how much ice cream is sold at 21 degrees. I said it was about 450 because 21 degrees is in this area. And then it says, can you predict how hot it was if it was $600 that was sold? So over here, $600, I would say it's about 24 degrees Celsius. Okay? All right, so I'll see you guys tomorrow. Have a good one.